Hello again, everyone. We're looking at now case 2 from our notes of 5.3, our partial decomposition of rational expressions. This case has a grouping of linear factors that are repeated. Now, this one is already in factored form, which is great. What we would do is break down those factors into pieces, such as our x is a single, just like our case 1. After a linear comes a constant, so this would represent a constant number above. Now, with the repeat, this is where some students do get a little bit confused. If we think of a factor tree, such as take the number 8, you would factor that down to 2 times 2 times 2 to its primes. Well, you could represent those prime numbers as 2 to the third to be 8, or 2 times 2 squared, which would be 8, or just the 2's represented singly. Now, we're going to do the same thing with the binomial. This one's repeated 3 times, so we want to represent it as each of those pieces. X minus 1 to the first, x minus 1 repeated twice, and then x minus 1 repeated 3 times. We need to represent each of those groupings in our first step. Then after that, we can jump right to step 3, where we multiply by our common denominator, which happens to be the x times the x minus 1 to the third. Now, I could have written that out 3 times instead, but for spacing wise, I kept it together. Now, when we multiply it through, let's look at the result. The x's on the first one will cancel, which will leave me with x minus 1 to the third. So, well, there it is. And then b, x minus 1, there's one of them out of this grouping. That leaves 2 left over, plus the single x, the monomial of x, and so forth all the way down. Now, once we have done that, we're going to, again, just like in case 1, multiply everything out. So I did x minus 1 to the third. I multiplied x minus 1 times itself, got that quadratic, and then times it again by x minus 1, which gives me a cubic. I did not show that part of the work. Just remember, this is 3 sets of x minus 1 multiplied out. And then again, with the same thing over with b, I did x minus 1 times itself, and then timesed it by x. And this is the reduced form all the way through. Then, as we did in case 1, we want to multiply that constant throughout. So I take the a value and go throughout each piece, the b value, go throughout, c, and then d. Then we get to our fun part of regrouping them, and that's where my markings come into play. Sometimes I'll scratch them out or mark them out as we go. But we have, of the x cubes, I only have 2 of them, a positive a and a positive b. Of the x squares, I have the coefficient negative 3a. Remember, a is a number, so this will be a number. And then minus 2b plus c from over here. And then our x's, again, that's my triple lines. You can see where I did that. And then the last one, I only have one constant, that is negative a. Our next step will be to write our equations. This one is really nice for us. You can see that our coefficient on the left-hand side, I do not have an x cubed. Therefore, a plus b will equal 0. Of x squares, I do have a coefficient of 1. So my coefficients on the left and the right do equal. And then my solid x's, I do not have any x value. Therefore, there's 0x on the left, which then equals the 3a plus b minus c plus d. And lastly, our constant, a negative a equals to 1, and that's super nice. As you can see, with all four equations not having four variables, we can easily go ahead and solve for a, b, c, and d. Equation 4 is already set up for us. Just a has to be the positive, so multiply by a negative 1 or divide by a negative 1, and you get a equals negative 1. On my step 2 of solving, I took equation 1 over here and our a value and put those together and got our b value. Then we're down to knowing what a and b are, so I take equation 2 and I can substitute in our value for a and our value for b and get our value for c in the end. And then lastly, we did the same thing by using equation 3 and all the values of a, b, and c to find value of d. Once we've had all those values, we go ahead and go back to that second step where, let me go ahead and hide this for a second, where you can then put in the values of a, b, c, and d into its factored form. Now notice I do not have the 0 over x minus 1 squared as a binomial squared. That's because 0 divided by anything is still 0. There is no need to have that in our equation if there is nothing, or in this case, 0 represented. We end up with our final decomp all broken down. And I hope this helps again. This is case 2, and case 3 and 4 are shortly to come.